Thus far, we have dissected the blurry boundaries of space, time, and the physical self. We have identified our experience as being born of this partially understood physical world, whilst also being a limited perspective of the less understood, grander, infinite reality. We've begun to highlight the perspectival nature of emergence, revealing how our subjective interpretation of self might be just as valid a description as any offered by the physical. Both correct, both infinitely incomplete. But much of what we have covered has been contained to the physics of our world, with any mention of experience only ever offered in terms of this emergent character, yet another side of a multifaceted coin. We shall begin to dissect consciousness more rigorously across the following season. But for now, what seems evident is that experience is inextricably linked to the physical. What we must now question is, how important is this link? And what are its rules? Across the previous chapters, we have also begun to educate ourselves on the basics of quantum mechanics. The added benefit that this might offer is that it enables a finite description of the physical self, and so a language that can be used to describe this physicality in its relation to experience. For if the physical self is knowable, then it offers a philosophical ground to safely discuss concepts such as the digital replication of experience, the uploading of self, or, as it's more dubiously referred, the teleportation dilemma. Good morrow, fellow humans. My name is Sean, and I am obsessed with infinity. So join me as I attempt to unpick the infinities of what is. In 1998, the world's first teleportation took place. Physicists at the Caltech Institute of Technology, with the assistance of 2 European teams, teleported the quantum state of a photon over a distance of 1 metre. That's right, it actually happened. And across the following 2 decades, the trials have only continued to advance. In 2004, teleportation was achieved over distances of 600 metres, then 16 kilometres, 97 kilometres, and most recently in 2017, a group of physicists from the University of Science and Technology in China, along with researchers from the Austrian Academy of Sciences and the University of Vienna, teleported high-dimensional quantum states over 7,600 kilometres from their ground base in Tibet to their specially designed Messius satellite. Which all sounds very impressive, but I agree, there is a slight hint of ambiguous language thrown in there. What exactly does it mean to teleport the quantum state of something? Thanks to our science fiction educations, most of us will be familiar with the 3 types of teleportation. First is the Harry Potter method, where one body disappears and by some form of magic reappears somewhere else instantly. The second is the Star Trek method, where a body is dematerialized at one end, beamed to a new location and recombined at the other end on the molecular level. The third, currently used by physicists, is that of recording a system's atomic structure, entangling this with a second site and reforming the original body using atoms found locally at the other end. In this version, it is the atomic information, or the quantum state, that is being teleported, not the matter itself. However, the information is still being transferred across vast stretches of space via completely non-connected means, and the results are no less reflected in a physical form. The system literally evaporates at one end and re-emerges at the next. So for all intents and purposes, the copy can be considered the exact same body, right down to the very spin of the atom. This is the power of quantum entanglement. Entanglement is a feature of quantum objects that occurs when any two are brought close to one another, resulting in a mirrored pair. You can think of this as a pair of dice that, when rolled together, always make up the number 7. If one die lands on 3, we know instantly that the second has already landed a 4. An instantaneous effect that occurs regardless of whether the two particles are in the same test room, the same city, or even the same side of the universe. A non-local communication operating beyond the laws of classical physics. But it is this very feature, along with superposition, that has enabled the modern miracles of quantum teleportation and quantum computing, both of which are very similar in how they operate. The basic idea works like this. In a classical computer, an electronic bit can only access the binary state of either 1 or 0, whereas a quantum bit, or qubit, can access a combination or a superposition of both simultaneously. Add to this the power of entanglement, and that superposition can now access not only 1, 0, or a combination, but the collective combination of an entire series. For example, just as a 2-bit classical system has access to one of 4 states, 0, 0, 0, 1, 1, 0, or 1, 1, an entangled 2-qubit system can access all 4 of these at once. Raise the count of entangled qubits, and we raise the count of potential calculations by an equal order of power, 2 to the power of however many qubits, meaning that the count of potential calculations grows exponentially. So much so that for any classical computer to simulate a mere 400 qubits worth of processing, it would require more atomic-sized classical bits than could fit in the entire observable universe, a count that quantum computing has already surpassed. How this is similar to teleportation is that it is this same entangled superposition of information that gets shared between particles, be it over a much greater distance. Unfortunately, it's not quite as practical as all that's shown in the movies, as it's only after we have physically trekked each of our entangled pair to their respective start and end positions that the teleportation system can be put into action. Another less than practical aspect of quantum teleportation is that a physical measurement made at Site A must be communicated classically to Site B before any transportation can be declared complete, thus negating any hope for faster-than-light communication. However, there is an upshot, as this act of measurement is also responsible for collapsing the superposition, destroying the original information at Site A and denying any capacity for cloning. This is what's known as the no-cloning theorem, and it is in this sense that the data has literally left Site A and arrived at Site B purely via the entanglement link. In the case of teleporting something more substantial than a single qubit, say a packed suitcase, this would require an entirely stable entanglement link to be established between the atoms of the suitcase and a like-sized cloud of entangled atoms at both the teleportation system's start and end points. Though the mathematics suggest that such a feat is possible, the experimental hurdles are vast and many, making it extremely unlikely that this will ever be mastered. Firstly, the level of stability needed to hold an entanglement link typically requires that a system is protected from the decohering effects of the environment. Even a stray photon hitting the name tag would be enough to tip the balance, not to mention the astronomical amounts of data storage that would be required. But suppose that such a device were to be created. This would mean that the original suitcase at Site A would first dematerialize into a cloud of its atomic parts, each with no particular location in either space or time, before moments later reconstituting at Site B with all of its original contents. It's not likely, but it is philosophically relevant, as it is here where our scientific shoreline of understanding again meets the philosophical, right to the heart of our search for the I in the physical. Because if I were able to teleport you by this method, it would mean that your entire physical body would first have to be destroyed, put into an informational superposition with no certain degree of location or momentum, only to be rebuilt with entirely new atoms. So the question that now so brazenly calls for our attention is it the same you who materializes at the other end? On first assessment, this is simply a copy. You were killed in the dematerialization process. But this new you is identical in every way. As we said, right down to the very spin of your atoms. Every memory, feeling, intuition, passion and desire would still be there, assuming all went to plan. And as far as this new you is concerned, it was they who stood on the transporter, and they who experienced the flash of light moments before reappearing, clear as day on the second platform. But is that true? As previously discussed, the physical self is constantly reshuffling its atoms. Atoms come and go every day. So how is this any different? I suppose one could argue that the difference is that whereas in our ordinary minute-by-minute aging process we only shed partial amounts at any given moment, this is an entire reset. But then, how is that different to the difference between you now and your child self? That body has been entirely reset. The you of the past, or the you of the future for that matter, doesn't exist. Essentially, they're dead. Though, as pointed out, we do not mourn their loss, because it is the continuation of experience that we heed as important. And so, is it not this same continuation of experience that gets passed from one set of atoms to the next during teleportation? Okay, but I hear you saying it's still not the same total and instant reset. The change from child to adult takes many years, at only a few cells a day, right? Well, actually, somewhere around 300 million of your cells have died just in the time it's taken for me to read the last 2 paragraphs. We lose trillions of cells every day. But I take the point. It's still relatively gradual. So what if we transferred the information cell by cell? Would this make any difference? Let's examine this idea in a different way. Today, we use technology in almost every aspect of our lives. Recklessly, we embrace its ever-maturing integration with an equal share of passion and passivity. Irrespective of the violence that this gift of instant communication has caused, we contentedly slip the world into our pockets, utilising it as an extension of our working memory, allowing it to analyse, shape and coordinate our very intentions, measuring our desires and helping us navigate the immensity of our world and its endless content. But so what? After all, this revolution has been underway for some time now. It was back in 1957 that the first cochlear implants were offered to the world. These miracles of the modern age converted ordinary sound waves into digital signals, which, when transmitted to the patient's cochlea via a cable under the skin, ignited the sense of hearing in the minds of the deaf. Since 1997, a once inconceivable cure has been used to remove the symptoms of Parkinson's disease. Deep brain stimulation involves placing a neurostimulator deep within the patient's brain, increasing the brain's blood flow and the release of natural neurotransmitters, reforming connections between defective regions. And such bionic upgrades have only continued to advance. Today, smart prosthetics are so clever that they can take movement directives directly from the brain. These are just a few examples of the bionic revolution that we have openly incorporated into our human narrative. And why shouldn't we? However, it does foreshadow a curious path for our species, one which, with little stretch of the imagination, can give insight into how future generations might expand upon this trait of integration, from nanobots that enhance our nervous systems to hyper-advanced versions of our mobile technology embedded directly into our brains and body. Sooner than many may think, the idea of holding a device in your hand will seem archaic. And once we have leapfrogged the few straggling moral issues which current generations seem to only nonchalantly flirt with, we shall find ourselves in a world where the bionic upgrading of both body and mind is considered a relatively mild affair. Very soon. In fact, it's already begun. In 2024, building upon more than 3 decades of brain-machine interface research, or BMI research, the first human trials began for Neuralink's BMI module. The initiative has set itself the challenge of delivering a long-life, two-way wireless device that connects the human brain directly into the digital world via a standard Bluetooth receiver that can be implanted via a surgery no less accessible than the laser eye surgery, or LASIK, currently performed in standard eye clinics worldwide. Under a local anaesthetic, patients would be contentedly leaving their brain clinics within hours, happily syncing themselves to their devices. Using a specialised robot, 1,024 electrode wires, each 1/10 of a diameter of a human hair, 10 microns across, are attached to the cerebral cortex, recording and stimulating electrical signals at 200 megabytes per second for every electrode wire. This is then computed by an algorithm built into the chip, which processes these signals within a minuscule 900 nanoseconds, meaning that the chip will have processed our intentions before we are even consciously aware of them. And not only will technologies of this type give a voice to the silenced, sight to the blind, and freedom to the impinged, but eventually, this remarkable two-way digital telepathy will advance our mortal abilities beyond their natural restrictions, surpassing the bandwidth bottleneck that is our reading, writing, and even speech. The life and death necessity for these skills simply evaporates. Memories will be shareable instantly, and even our vision shall be open for manipulation as we send our augmented and virtual realities directly to the brain's visual cortex. And from here, the possibilities are endless. So let us imagine this world. Our minds integrated with digital processors so small that they operate on the same quantum scale as the biological systems they enhance, where future humans routinely upgrade their capacity for both learning and memory. However, due to both the finite nature of our biological system and the ever-expandable nature of the bionic, mental actions start to be increasingly performed outside of the individual brain. However, as this trait continues and the brain's natural plasticity embraces its new norm, it becomes very hard to distinguish what is still us and what is the machine. For as far as the experiencer is concerned, it is all still us. Like the recipients of the cochlear implant, the deep brain stimulator, or the smart prosthetic, shall we each consider the machine and its influence to be as much a part of the self as any original description. Some theories even propose the potential human-machine hive-like mind, a technology-sustained global consciousness. However, as we continue to imagine this world, the idea arises that there may one day come a point where the biological system becomes more of a hindrance than a help. When 99% of mental functions are happening within this digital expansion, why retain the final 1%? Perhaps we might vacation in virtual space, leaving our bodies in stasis until our conscious experience returns. Or perhaps for environmental reasons we abandon the body altogether. But at this point, is the original self dead? If so, what point did we cross the line? After all, the experience is still theoretically intact. Unlike teleportation, never once did we break the thread. This newly placed interpretation of the self is just as connected to the you of now as the you of your future self is. Connected by the ideas, memories, emotions, and a sense of experience through time. Now, for those philosophically educated among us, you may recognize this story as one far older than the world of technology we are using to unfold it, as this is nothing other than the famous Ship of Theseus paradox. The Ship of Theseus is a story penned sometime in the 1st century by the Platonist philosopher Plutarch. It tells the story of a ship that, after many seafaring adventures, began needing to have its parts replaced. One by one, each plank and board would be swapped out, new for old, until nothing of the original vessel remained. But at this point, is it still the Ship of Theseus? If not, at what point did the transition occur? Was it after the first or final piece? Halfway, perhaps? Or if we do consider it the same vessel, what would happen if all the discarded pieces were later collected and put back into their original arrangement? Would there now be 2 ships of Theseus? In terms of the rebuilding of self, I would think that this identity appears far more inherent within experience than within any such body. And so if that be the case, the new ship must be considered the real one. But, as shown in our discussions concerning the physical brain, the experience is still stringently attached to the physical and cannot exist without it. Though the no-cloning theorem of quantum mechanics may refuse us the ability to put those original pieces back together to create a second original self, the pieces are nonetheless a part of our story, and so they cannot be discounted. However, this does highlight the continuous nature of the system we call self. For it seems that the subjective perspective is not merely attached to the system we call body, but to the system we call universe, as ultimately both body and environment are one and the same. Both ships are the Ship of Theseus unitedly, just as both selves, pre and post teleportation, are the continuation of the true self. It's just that each identity is only ever contained to its own finite truth. The self cannot be known by its parts, though the parts can be known by the finite frame of subjectivity. In other words, the subjective boundaries to one or another identity are only ever considered emergent from within a finite perspective. Beyond this, wholeness prevails. We are the infinite attempting to look back at itself. But to look back from some perspective, we must consider ourselves separate from the universe, unique and individual. Quote, "A human being is a part of the whole called by us the universe," says Einstein. A part limited in time and space. He experiences himself, his thoughts and his feelings as something separate from the rest, a kind of optical delusion of consciousness. End quote. The experience is of the physical, but equally the physical is of the experience. As the nature of the physical universe defines that which is experienced, so does the nature of the experience define the universe it encounters. Two sides of the same coin, two perspectives of one whole. Let me put it another way. The early universe bore no consciousness, at least none that resembled our own. And yet, contained within this early universe was the potential for all such consciousness to exist, for every thought that ever has or ever will be. Though when our brand of consciousness did finally emerge, no new elements were added to the mix. All that was before still is now. It's just that now, reality can appreciate itself from this new finite angle, the angle of a living being, experiencing itself in space and time. This, it appears, is just what universes do when they are busy being new. But due to its finite nature, our perspective is still contained to its limitations. In our case, those limitations are being born in and of space-time. As said by the 18th century philosopher Immanuel Kant, quote, "Space and time are the framework within which the mind is constrained to construct its experience of reality," end quote. An idea worth pondering over because, as discussed, space and time are thought to be mere fields of interaction threaded amidst a still greater infinite. As we exist in and of this universe, so does the universe exist in and of the infinite. Thus, we too are this infinite. But if we are the eternal, is it right to say that we die? When the subjectivity blinks out between teleportations, are we removed from the whole? What is lost upon death? I would think that what we lose is the subjective experience of yet another false boundary. We could confidently describe many various and conflicting perspectives of this life story, each correct, but each infinitely incomplete, as each perspective is defined by its own horizon, some measurable mathematically, some not. Perhaps we could see our life story as living endlessly outside of time, in some perspective of reality beyond time, such as a block universe or muddled quantum foam. We could also perceive ourselves as merely a dance of cause and effect, happening solely within time, as finite quanta playing by the rules. Or even as some unbounded sea of pure consciousness, blending in and out of its many alternate perspectives. Or we could just see our story through the eyes of a single other. There are an infinite count of perspectives from which we could perceive the reality of our story. Many conflicting, all with an inherent truth, but all ignoring some part of the greater picture. But this is what we do. This is what we are. We are finite frames with finite understanding and finite experience. We divide reality into time, into space, into us and it. For this is what it is to be alive. Perspective. But there is one perspective that we do and should hold up to be the utmost precious. Our experience, as it is in this very moment, false assumptions and all. Yes, we can describe the self as an eternal weaving of reality, existing beyond the subjective boundaries of time and death. But we can also define ourselves as being the finite. For within this true yet very incomplete perspective, There is only a finite count of vibrations, a finite count of moments, where the infinite refers to itself as you, as I. But this is not a small or less important description of the self, since, as we showed in our dissection of scale in the first few chapters, no perspective can ever truly be big or small compared to the whole, because there is no hierarchy of importance nor any ultimate truth that can be contained to any such finite perspective. Therefore, it is all valid, all magical, and all real. It just happens that this one in an infinite, this you, right now, here, in this moment, requires that you experience it in time, finitely. If it didn't, it wouldn't be the same you, the same experience. And so it shall continue, until your finite experience reaches the edges of this temporary description and blends uninterrupted into its next. There we go, folks. That is the end of Act 1 for the Infinite now. I'm going to take a couple of months off now. There's some writing that I'm going to need to get done for next year, and there's a bunch of other things that I want to also do as well. So we'll see how the next couple of months unfolds for me. But I will be back in January of 2025 for Act 2. This first act has been focusing on the idea of the physicality, how we can understand ourselves in relation to this physicality, this physical universe. And next year we're going to be focusing on the experiential, trying to understand consciousness in a bit more detail. And the third act will do some point down the line even further, possibly in 2026. We'll see how we go, and that will be the Infinite. But this is where we've ended off for the end of this act. I hope you've enjoyed it. I hope you've been getting involved online on the YouTube page, putting in your comments. I've had many beautiful comments coming through this week, so just want you all to know that I appreciate it very much, and it really helps me to be inspired and get back in here and work on this for us all. So thank you very much. I hope you all have a wonderful break over the Christmas period, and I shall miss you. Till next time. All right, much love. I hope you all have a wonderful, wonderful week. All right, bye-bye.